Today we are going to learn about advanced looping techniques with Python generators. We'll explore how to implement generators to streamline data processing tasks efficiently. Welcome to our video on advanced looping techniques with Python generators. Generators play a critical role in Python, especially when it comes to processing large datasets efficiently. They help in conserving memory and allow for lazy evaluation, making them an essential tool for any Python developer. In this video, we will delve into what generators are, how they differ from regular functions, and the benefits they bring to the table. By the end of this series, you will be able to harness the power of generators to improve your data processing tasks significantly. Let's get started. Python generators are a special type of iterable, like lists or tuples. However, unlike these data structures, generators don't store their contents in memory. Instead, they generate items on the fly, which makes them incredibly memory efficient. This is particularly beneficial when dealing with large datasets or streams of data. Generators are defined using functions and the yield keyword, which we will explore further. By using generators, you can iterate over sequences without the overhead of storing the entire sequence in memory. This makes them ideal for applications such as reading large files or processing big data streams.
At first glance, generators might look similar to regular functions. However, there are fundamental differences. The most significant one is the use of the yield keyword instead of return. While a function using return sends back a value and terminates, a generator using yield pauses the function, saving its state for future resumption. This allows the generator to produce a series of values over time, rather than computing them all at once and sending them back. This results in significantly reduced memory usage, especially for large data sets. Understanding when to use yield instead of return is crucial for writing efficient Python code.
The yield statement is what makes a function a generator in Python. When Python encounters a yield statement, it returns the value to the caller and pauses the generator's execution, saving its state. When the generator is called again using next comma, it resumes execution from where it left off. This can be repeated until the generator is exhausted. Using yield, you can create more complex loops, such as infinite sequences or pipelines of data processing steps. Let's look at a simple example, a generator that yields a sequence of numbers. This small change can have significant impacts on the performance and memory usage of your programs. Generators offer numerous benefits in data processing tasks. One of the most significant advantages is memory efficiency. Since generators yield items one at a time, they don't require storing the entire dataset in memory, which is particularly beneficial for large data processing. This lazy evaluation means you can start processing data before you've even finished generating it. For instance, reading a large file line by line using a generator allows you to process each line as it's read without loading the entire file into memory. This not only saves memory but also can improve processing speed, especially in I/O-bound applications. Lazy evaluation is a concept that goes hand in hand with generators. It refers to the practice of delaying the computation of values until they are actually needed. This stands in contrast to eager evaluation, where calculations are performed immediately. In the context of generators, lazy evaluation means you only generate values as they're requested, which can significantly reduce memory usage. This is particularly useful in scenarios where you may not need all the data at once or when working with infinite sequences. Lazy evaluation can lead to more efficient code, especially in data-intensive applications where resources are a concern. Generator expressions and list comprehensions share a similar syntax, but they have very different behavior. A list comprehension generates an entire list in memory, while a generator expression generates values one at a time using the same lazy evaluation as a generator function. This makes generator expressions more memory efficient, especially for large datasets. The syntax difference is subtle. List comprehensions use square brackets, while generator expressions use parentheses. Understanding these differences allows you to choose the right tool for the job, optimizing both performance and memory usage in your Python applications. Debugging generators can present unique challenges due to their stateful nature. Unlike regular functions, where you can step through the code line by line, generators require special consideration because they yield control back to the caller. One effective technique is to use print statements strategically to understand the flow of data. Additionally, Python's PDB module can be useful for setting breakpoints and inspecting the generator's state. Testing generators involves ensuring they yield the expected sequence of values. Writing unit tests that exhaust the generator and check its output is a good practice to guarantee correctness.
Generators are widely used in real-world applications due to their efficiency and flexibility. In web applications, they can be employed to handle large streams of data, such as logs or real-time user interactions. In data processing, they allow for processing large datasets with minimal memory usage. Generators are also beneficial in machine learning, where large datasets are common and memory efficiency is crucial. By yielding data as needed, they enable more efficient training and evaluation processes. Understanding these applications can help you leverage generators to optimize performance in various projects. Performance analysis is crucial to understanding the impact of generators on your applications. By measuring execution time and memory usage, you can identify areas for optimization. Techniques such as minimizing function calls and reducing overhead can lead to significant performance gains. It's essential to balance memory efficiency with processing speed, as generators might introduce overhead in some scenarios. Using profiling tools can help you identify bottlenecks and make informed decisions about when and how to use generators. Through practical examples, we can see how these optimizations play out in real-world scenarios. While generators offer many advantages, they also come with potential pitfalls. One common issue is misunderstanding the stateful nature of generators, which can lead to unexpected behavior. Ensuring compatibility with other functions and handling exceptions properly are also crucial. It's important to recognize the limitations of generators, such as not being able to rerun them once exhausted. By following best practices and learning from mistakes, you can avoid these pitfalls and leverage generators effectively in your applications. To effectively implement generators in your projects, it's essential to identify suitable use cases where their benefits shine. Designing efficient generators involves understanding the flow of data and the requirements of your application. Integrating generators with existing code can sometimes be challenging, but with careful planning, it can lead to significant performance improvements. Testing and validation are crucial to ensure that your generators work as intended. By continuously learning and improving your generator implementations, you can maximize their potential in your projects.
In conclusion, Python generators are a powerful tool for efficient data processing. We've explored how they work, their benefits, and how to implement them effectively. Generators allow you to handle large datasets with minimal memory usage and improve the performance of your applications. As you continue your Python journey, consider experimenting with generators in your projects to solidify your understanding. Remember, practice makes perfect. There are many resources available for further study and learning, so take advantage of them to deepen your knowledge. Thank you for joining us on this exploration of advanced looping techniques with Python generators.